is equal to 7 times 9 is 63. Yeah, it works. Hey guys, in this video, I'm going to test QwQ, a new model released by Alibaba. So QwQ is the reasoning model of the Q1 series, and compared with traditional instruction tuned models. The QwQ model is capable of thinking and reasoning according to the team. Present some benchmarks here, but I mean, we haven't seen these benchmarks in these leaderboards, including this the mathematical reasoning leaderboards, live bench leaderboards. So we haven't seen them appear in the leaderboards. But I mean, what's fun is that we can have a test of QwQ, because QwQ is only has 32 B parameters, so it is a medium-sized reasoning model. We can test that. I mean, if it can be run by a single GPU, like A6000 I have, I want to test that if it can be loaded into a single GPU, and run how fast it run in a single GPU. Here are some of the metadata of the QwQ. Of course, I believe that even if it has the 131,000 tokens context length, I think for a single A6000 we might achieve just a bit of it. So they also provide the demo to access the QwQ through the chat, so you can test it. I think it is the performance is quite impressive. So as a quick start, we can directly copy paste these codes into a Jupyter notebook and run it, see what problem we have. So actually I have run the QwQ full model in the Jupyter notebook terminal. So you can see that right now it is loading the model into the memory. So after it's loaded into the memory, it takes 41 I think 41 gigabytes of the memory. So this memory this A6000 has 48 gigabytes of memory. So we can have a test. So it takes around like 20 seconds or 30 seconds to generate just 10 tokens. So you see, it has already been have occupied 90% of the GPU calculations. But I mean, I'm not sure that maybe this model has not been fully optimized, because the power usage is far below the 300 watts. So usually when I run small models, they almost have 100% of the power consumption. So okay, now it's finished. It is around 3.4 seconds per iteration. So the output is okay. So I need to figure out how many. Okay, this is not quite fun, because the generation speed is so slow. So that I mean, I'm going to close this one, and I further tried the quantized model. So according to the documentation, currently That's the smallest model is the I2 XSS. So I tested the IQ Q2M model. So it is usable, but I mean, let's just have a quick test. So let me see if it is this one. Okay, so first we can test it with Olama or VLM. So, but I mean, in this video I just use the Llama CPP Python. So first we have to install the Llama CPP Python, and then we load the model. So this model is loading into the CPU. I think I'm pretty sure that okay. So it loads to the CPU. So if we want to it to load to the GPU, we need to add a command line. So parameter shows that on GPU layer is -1, so it is assigned to CUDA A0. So now you can see that it has almost 1 GB of the memory. So in order to make it has a longer context, we have to explicitly define the uncontext is 20,000 or more. You can define 130,000 tokens if you like to. So let's run it. Run this GGUF test file to see the outputs. So right now you see we have two model loaded into it. So I think it's have been finished. So this is a context. For the context, it has 170 tokens per second. This is the output tokens, 38 tokens per second. So okay, so let's do a real testing case. So instead of just testing codes, I just write a code to write a simple chatbot to chat instead of just print out a single one a single response to the answer to this answer. So here is what we can do. So first let's just make a GGF demo chat.py. I'm going to share this make file as well as the codes with in the GitHub repository. So for this chat, so in order to use the GPU for the Llama CPP Python, you also need to make sure that you have this command line to reinstall the Python in your Python virtual environment. So in this code, what we do is that first we initialize the llama from the pre-trained model. I have downloaded the model from this quantization model, and here I define the history history of the conversations. It will have store the 5 pairs of the message. So I set the context window to 20,000 because if it will cause the out of memory issue if I define 131,000. So here I define a function of add message. Each message has a row and a content, and get a model response. For the get a model response, I define the temperature to 0.6, stream to true, max token to 10,000, 10,000, more than 10,000. So for the chat, it is a simple while loop um, uh, until user says that quit. Okay, so for the model, I downloaded the Q6K model. I check all these lists, so it shows me that it seems that this Q6K it has a very high quality, near perfect, and recommend. So I'm going to use this model instead of the Q8 in this evaluation. So let's first ask. So previously I tested a case. So can you write a calculator in nexjs with TypeScript? I use the app routes, tailwind, and tailwind. Um, so let's do a test. So it will actually actually think. I think traditionally that's people do this as a multi-turn to think about it. I think in this model it just think during the generation. So I put this calculator codes inside my Routine web app as a test. So I put this is the code generated by QwQ. So I tested the local host test here. You see that it gives a calculator, the front end of the calculator, including it with the format using the tailwind, and it has the handle operator, handle decimal places. It consider the handle equals and handle the number. So we can do a test. Suppose we want to 7 minus 8, it is -1. So there's an issue here is that it has a 2 plus. Let's say that this plus 8 is equal to 7 times 9 is 63. Yeah, it works. Uh, it works pretty well. So here you can clear it. So this is a simple calculator. So that's it for today. I'll put the codes in the GitHub repository and upload to my GitHub account. Thank you very much for watching. I'll see you in next video.